Hey guys, today we're on lesson 8.3, compound interest, and we're going to start with task 1. Alright, compare simple and compound interest. Banks and other financial institutions often pay interest to people who leave their money in an account, or a person may pay a bank interest or money that the bank lends to the person. The bank may pay simple interest where a certain percent or just the principal is paid at regular intervals. More commonly, banks pay compound interest, which is interest paid on both the principal and the accumulated interest. Farah wants to deposit $500 she earned from her summer job into a savings account. Her local bank offers two types of savings accounts shown below. All right, on the left, you'll see it says basic savings. There's no minimum balance, and they make 3% annual simple interest. There's another reward savings where there's a $500 minimum balance and 3% annual interest compounded yearly. Farah makes the spreadsheet shown below to compare the account balances she would have with the two types of savings accounts. All right, so you can see here's the number of years. Basic savings, 500, 515, 30, 45, 60, 75. So in the basic savings account, you can see that it increases by $15 each year. Now the rewards savings goes 500, 515, 530, 45, 546, 36, 562, 75. So they're paying interest on the previous year, not on just a basic amount. All right, so for each type of savings account, how is the balance after T years obtained from the balance after T minus 1 years for all time greater than or equal to 1? All right, so your basic savings account balance after T minus 1 years. So the basic savings adds $15 each time, and the reward savings multiplies by 3%, so 1.03. And again, that was given up here as 3%. All right, for each type of savings account, what is an equation that gives the amount A of money in the account as a function of time T in years? All right, so the basic savings account is going to be a linear equation where you multiply 15 times the number of years, and the reward is going to be exponential, 500 times 1.03 raised to the T power. How much money would Farah have in each type of savings account after 10 years? All right, so we can use this formula here to look. So if I pull up my calculator and I can do 500 and then plus 15 times time, so plus 15. And we're doing it for 10 years, so T will be 10. That's going to give us $650 in our basic savings account. All right, so for the other account, we're going to do 500 times 1.03. And this is exponential, so it's raised to 10 years. All right, and then hit enter. And this account's going to give us $671.96. So $671.96. All right, which type of savings account should she choose? Well, I would think the reward account, because clearly it's making more money than the basic account. All right, explain. Well, anytime you've got an exponential growth, that's going to grow faster than the linear equation. All right, that's all for task 1. If you have questions, let me know. 8.3, task 2. All right, model interest compounded yearly. If an initial principal P is deposited into an account that pays interest compounded yearly, then the amount A of money in the account after T years is given by the exponential growth function. Here's the function. A equals P times 1 plus R, your interest rate, raised to the T power, where R is the annual interest rate expressed as a decimal. All right, so in the picture it shows us that this bike cost $850 and it depreciates 20% each year. All right, Juan has $400 in a savings account that pays 3.5% annual interest compounded yearly. He wants to use the money to buy a used mountain bike in 3 years. The current price of a new model of bike Juan wants is shown, as is the expected rate at which the bike depreciates or loses value. Will Juan have enough money to buy a used model of this bike in 3 years? Find the amount in Juan's savings account after 3 years. Use the formula for the balance of the account with interest compounded yearly. All right, so here's our formula again. A equals P times 1 plus R raised to the T power. So Juan has $400, so that's his principal or his initial amount. And 400 times 1 is 400. So we know if he puts it in the bank and it gains interest, he's going to have at least $400 or more. So the 1 just signifies that the $400, we don't lose any money there. And then the interest rate is 3.5%. So you have to change a percent to a decimal. Remember, to change a percent to a decimal, you have to move the decimal 2 places to the left. If you do that, you get 0.035. All right, we want to know how much he'll have after 3 years. So T is 3. And then we can just simply plug this in the calculator and get $443.49. So if Juan starts with $400 in 3 years, he will have $443.49 in his savings account. All right, it says, why do you substitute 0.035 instead of 3.5 for R? Okay, so again, this was a percent and we had to change it to a decimal. So that's why we had to do that. All right, it says Juan's account will have a balance of $443.49 after 3 years. Estimate the cost of the bike Juan wants after 3 years. All right, so the value V of the bike after T years can be modeled by the exponential decay function. V equals 850 times 1 minus 20, and this was 20%. Remember in the picture above it showed us that it decayed at 20% per year. So 20%, again as a decimal, is 0.20. All right, so that reduces 1 minus 20%, gives us 80%. So 850 times 0.8 raised to the T power, and we want to evaluate that for 3 years. So let T equal 3. All right, if we do that, this model bike will depreciate. After 3 years, the bike will be worth $435.20. All right, so it says, why is the base of the exponential function less than 1, while the base of the function of Juan's account balance is greater than 1? All right, so this was an exponential decay function, and we know that because it was depreciation. Depreciate means it's going to go down in value. So your interest rate or the number inside of your parentheses is always going to be between 0 and 1. That means exponential decay. The one above was exponential growth because you put your money in a bank and you gain interest. So you're going to make money. So it's going to be greater than 1. All right. So it says the estimated cost of the bike in 3 years will be $435.20. Since Juan's account balance after 3 years has $443.49, and that's greater than the estimated cost of the bike after 3 years, Juan will have enough money to buy the bike. All right, that's all for task 2. If you have any questions, please let me know.